Okay, section 5.8, radical equations. Now the radical equations are very similar to just solving regular equations, except we have to get the radical away. And in order to get rid of the square root, we have to square it. In order to get rid of a cubed root, we have to cube it. So for example, if we had the square root of x plus 1 equals 2, in order to get rid of the square root, we square it and they cancel, and then we square the other side, just like we do in a regular equation. So we have x plus 1 equals 2 times 2 is 4. And then our job is to get x by itself, so we subtract 1 from both sides, and we get x equals 3. Now, we have to have an extra step. We have to actually check our answer to see if it actually works. So what we're going to do is we're going to plug 3 right back in there for x. We're going to take the square root of 3 plus 1 and see if it actually equals 2. And the square root of 4 does indeed equal 2. So we're finished there. Now once they get a little bit tricky, we have, let's say we had 3 times the cubed root of 5x minus 1, and that minus 2 is equal to 0. Now that cubed root is only going to here, and we have to try to work to get this by itself before we can actually get rid of it. So just like a normal equation, the first thing we're going to do is add 2 to the other side. We get 3 times the cubed root of 5x minus 1 equals 2. In order to get that alone, we're going to divide both sides by 3. We have the cubed root of 5x minus 1 equals 2/3. And then we cube it to get rid of the cubed root. We got to cube the other side. Something we also have to remember is the cubed gets distributed to both top and bottom. So we end up with 2 cubed is 8, 3 cubed is 27. Our initial job is to get x by itself, so we're going to add 1 to both sides. I'm going to change that to 8 over 8, actually to 27 over 27, so I have the common denominator, and I end up with 35 over 27. And then I'm going to divide by 5. When we divide by a number and we have a fraction, we multiply by the reciprocal. We can simplify that, and x is equal to 7 over 27. And that is our answer. We can go ahead and check that by plugging into the original, and it comes out correct. Sometimes it won't come out correct, and we have what's called an extraneous solution. That's why it's important to check.